Hello, welcome back to this video. This is 5-5, the second video in a series of 2, and we are talking U-Substitution, and this is kind of your last resort as an integration tactic. And I'm going to do my best, I promise, not to reference Papa Roach or to reference Soulja Boy with all this U-Substitution being the last resort. So without further ado, let's talk last resort. And a disclaimer, this is not for the weak-minded, okay? So this is kind of tricky and very, very useful, especially going forward in calculus. Whoa, the lights turned out. But I have to run around every single time my lights go out. But very, very useful, okay? Last resort. So let's go ahead and get to it. So it says, for more complicated integration problems, simple rules for integration might fail, and you may have to take some type of substitution in order to integrate. In this course, the common substitution will be U-substitution. And here's what we do. We let U be whatever the radicand is. And if you forgot what the radicand is, there's a visual kind of reference for you. Okay, and we're going to let that part of the expression be u. Now, this will change the variable. We're going to go from x's to u, hence why it's called U-substitution. Okay, and it says, note, you should use this method of substitution only when simpler methods don't work. This should be your last resort. Last resort. Okay, so here's the procedure, and honestly, this is kind of complicated. It'll be much simpler when we walk through it, but you can have this here for your reference. So here's the procedure that we're going to follow. We're going to take whatever the radicand is. We will set it equal to u. Okay, and then step 2, we'll solve for x in terms of u, and then we will differentiate the equation. Okay. And find dx. All right, then we'll go ahead and substitute u expressions in for x expressions in the integral, and then we will go ahead and integrate. Okay, so integrate. And they say here, note for most often dx does not equal du. We'll see that here, but that's not often the case. Okay, and then the last step, we have to go ahead and substitute back. All right, so let's go ahead and look at an example. Here is example 7, and we're asked to integrate. And before I get to U-substitution, I'm going to ask myself, okay, can I integrate this term by term? Can I just go ahead and integrate each term? Well, no, because I have multiplication. So then my second choice is, okay, do I have a hook-on factor that I can use? So I'm going to look. I'm going to say, okay, what's the hook? And here the hook is 1. Now notice I do have a 1, right? You have a 1 everywhere, always, but I don't have a x in my hook, so that doesn't take care of the x term. So I'm kind of out of luck. So what we're going to do here is we are going to use U-substitution. So I'm going to say, okay, I want to let u equal x minus 1. That's my radicand. Okay, so this is step 1. Okay, then step 2, I'm going to go ahead and I'm going to solve for x. I'm going to say, okay, u plus 1 is equal to x. All right, I did that. And then step 3, which is also kind of step 4, is we're going to differentiate both sides. So du is equal to dx, and we found our dx. Okay, so then, okay, what we're going to go ahead and do is we're going to substitute into this formula. So I'll go ahead and note that x is equal to u plus 1. So u plus 1 times the square root of u, okay, and dx is du. So all I did was substitute, and I kind of don't like u. Sorry, I know you're like, oh, Schwarberg. Okay, u to the power of 1/2. Okay, so what I'm going to do here is I will distribute. So I have u to the power of 3/2 plus u to the power of 1/2, and this is du. Okay, so all I did, right, was just distribute this in. Okay, and then we're going to go ahead and integrate. So I have u to the power of 5/2, and I'll divide by 5/2, and then u to the power of 3/2, okay, plus c. So I went ahead and I integrated, right? This is, well, here's step 5, substitute, and then right here, step 6, we went ahead and we integrated, okay? And then step 7, you want to integrate or substitute back. So I'm gonna now get out of the u's. So I have 2/5 times u to the power of 5/2. So what is u? U is x minus 1. So I put in here x minus 1 to the power of 5/2 plus 2/3 times x minus 1 to the power of 3/2 plus c. And ladies and gentlemen, that is our solution. Okay, so there you have it. All right, pretty easy, right? Even you can do it. All right, here's number 8. Number 8, we're gonna go ahead and ask ourselves, okay, can I integrate this? Well, it's pretty ugly, okay? I wouldn't even want to touch this with a 10-foot pole. But you know what kind of gives it away is the square roots. Anytime you see a square root symbol, that's gonna be a hint, right? That will most likely be a U-substitution. But if I was to look at this, notice, right, my hook factor is just 2. So I have a 2x minus 1 in the numerator, so I'm kind of out of luck. So we'll go ahead and start that process for U-substitution. Step 1, I'm going to say, hey, u, 2x plus 3, that's u. And then we're going to solve for x. So we get u minus 3 is equal to 2x, which makes u minus 3 over 2x, and I'll simplify this. You'll see why I'm doing this in a second, but u minus 2 over 3/2 is equal to x. Okay, and now that I've solved for x, right, I want to go ahead and I also need to differentiate each side. Okay, so 1/2 du is equal to dx. Okay, and there you have it. So that's the 4 on dx. All right, so now what we're going to go ahead and do is substitute. Step 5, substitute. So I will integrate 2x minus 1. Well, I have a 2. And notice I don't really have anything for 2x minus 1, but I do know what x is, right? X is here. Actually, scratch that. It is here. Okay, so I'll just substitute this in. So u over 2 minus 3/2, close parentheses. Okay, times, and I have the square root of u. I don't want to confuse you guys. I'm going to do this. Square root of u, right? 2x minus 3, that is this value here, right? Okay, so square root of u. All right, and then dx is 1/2 du. So times 1/2 du. Okay, and let's clean this up. Now I'm going to take this 1/2 out back here, and I'm going to move it to the front. Okay, I'll just put that multiplier out, and that's legal. We can do that. Okay, and then notice I have all these terms over 2 being multiplied by 2. They kind of disappear. So, and I'll leave this in green here, right? U minus 3, right? Because these cancel with those 2's. And then I have multiplied with u to the power of negative 1/2. And I'm sure you're okay with that. I hope you're okay with that. You should be okay with that, right? You are? Good. All right. So there we go. Okay. So now, I mean, this still is looking pretty gnarly, but what we can do is we can distribute. I'll distribute this u back inside. Okay, so I have 1/2 of the integral, and we get u to the power of 1 times u to the power of -1/2 minus 3u to the power of -1/2 du, and we will simplify this. 1/2 u to the first times u to the -1/2 power, that is just u to the power of 1/2, right? You add those variables, or add the powers, I should say. That is the product power property. 3u to the -1/2 du. Okay, now it's looking good. Now we can go ahead and we can do step 6, which is integrate. And you're like, what? Oh, that was step 5? Yeah, all that was step 5, and kind of like cleaning house. We just needed to organize it and get it ready for visitors, right? Do you ever have to do that? You have people coming over, and so you got to clean the whole house. It's like, why even have a party in the first place? It's just going to get messy again. Anyway, I digress. Okay, so we go ahead and integrate, and I have 1/2, and I'm going to put a bracket out here, right? I'm integrating the right side, so this becomes u to the power of 3/2 all over 3/2 minus 3u to the power of 1/2 over 1/2, okay, plus c, which actually c is included. Don't want to exclude c, that poor constant. Doesn't even know its identity, okay? And I'll go ahead and rewrite this. So this is 1/2 times 2/3 u to the power of 3/2 minus 2 times 3u to the power of 1/2 plus c, and then we'll go ahead and multiply. I know you guys are pretty frustrated right now. You're like, all of this? The answer is yes, all of this. There's 1/2 cancels with this 2 and this 2 here, so don't be confused when they disappear. 1/2 plus c. You forgot to multiply the constant by 1/2. I didn't. It's just a constant value multiplied by 1/2 or divided by 2 is still a constant value. Okay, so there's your answer, except we need step now 7. We need to substitute back whatever u was, and I forgot because these problems are so long. U is 2x plus 3. U is 2x plus 3, isn't you? It is. It is 2x plus 3 to the power of 3/2 minus 3 times 2x plus 3 to the power of 1/2 plus c, and there is your answer. That's your answer. But I kind of want to go ahead and rewrite it because I'm crazy. This is 2x plus 3 cubed divided by 3 minus 3 square root 2x plus 3 plus 3 plus c. That is beautiful. There it is. We just integrated using U-Substitution, right? So go ahead, sit back, admire your work because it wasn't easy. Calculus isn't easy. Math isn't easy, right? Otherwise, everyone would do it. Okay, so be proud of yourself. Celebrate after you integrate these bad boys. They are pretty gnarly, okay? So remember, U-Substitution, it's a last resort. You want to use it at the end. A kind of a giveaway is when you have a square root. So maybe when you see a square root, right, you get really scared. Just like when you saw fractions, you used to see fractions. Okay, so there you have it. That's U-Substitution. Catch you next time. Peace. You!